Alright, are you guys seeing my computer screen now? Excellent. Alright, so this is the first of two hydraulic arm projects. They're related projects, it's kind of an idea, this idea where we're going to build one hydraulic arm and then we're going to improve it and add some features to it later on. And this is going to be similar to the design projects that we've done in the past, where you will keep a log book and take pictures and make diagrams and everything else, but there is also this worksheet to kind of follow along with. What I don't want you to do in this project is I don't want you to try to copy anything from this workbook. I don't want you to copy their designs. You can take ideas from them, but I don't want you to just try to do exactly what they're showing you here. In fact, it would be very difficult for you to do so, since I have not provided you the correct parts to do that. So you're going to have to do some improvising, first of all. For example, there's a little part down in here and another part up in here that is holding the syringes in place and allowing them to rotate. And I may have given you one or two of those, but I haven't necessarily given you enough of these black beans here to do this entire project using those. So you've got to do some improvisation in that way, but also you need to decide on your own kind of techniques. This project is this particular hydraulic arm will not necessarily be the best hydraulic arm to make. It's not necessarily the simplest either, and simple is often better. So I want you to use this workbook as a guide and as some information, to give you some tools to work with, but not necessarily to copy. It's not the point of it. Let me make this just a little bit better. Warning, there's choking hazards. No children under 3 years old. Okay, so the hydraulic arm in our competition is going to be really quite simple. They have all kinds of different ideas for hydraulic arm competitions, but our competition is going to be for the first arm to pick up somehow a tennis ball from the ground and lift it above 1 foot. So you're going to lift it 12 inches high. And that's all you have to do, is pick up the tennis ball and lift it up 12 inches. To start, our next hydraulic arm project, you will have to do more than that. But there are some things to consider here. Of course, you need to consider all the parts that you have that you could use to build this with. And you can see that they've used a lot of different parts here, and probably more. They probably used a bunch of parts that you're not going to have access to. I certainly didn't give you enough dowels to make your hydraulic arm out of dowels. You're going to have to probably use the wood sticks or something else. But also we have some online, let's see if I can find these. Copy. I may or may not be able to find these online tools. Let's see. Hey, looks like we did get it. So this first one is the Easy Engineering Guide, right? And they've just got some tools for how to use some of these materials in a little bit more complex ways. So you can go to, for example, you could go to reaming screws and slide stop material, page 5. You can go to page 1, 2, 3, 4, 5. Right here, you can see that you can get these dowels to fit through these black attachments by having just the right screws, just the right drill bit size. If you just have it just the right size, it will fit kind of tight, but it will still slide through. But just a little bit bigger drill, you can have a loose fit for easier movement, and that's a great idea if you're going to use things like wheels and gears. and that's certainly an option in these projects. Here you can also clip off the edges here, and you can get those dowels to slide through there a little bit more, and those dowels can be used for rotating parts, and you're going to have some of those in this project. The same thing goes with the gears and the belt drive, the pulleys. The pulleys are the ones that don't have the gears on the outside. They kind of have the funny little ridge. You can put those with some rubber bands connecting them. Also, they show you how you can use screws to attach things together. But more importantly, they have this slide stop material. So if you haven't used this yet, some of you have used them in your projects, but if you haven't, this material is actually yellow in your kit. It's just a tube. It's a rubber tube. And you can cut off little pieces of it and slide it over the dowels so that it holds things together. It holds the wheels, it holds wheels onto things, it holds rotating parts on, and that can be very useful. Of course, this section on hydraulics and pneumatics can be extremely useful to you, as you can see how the different parts can be used to set up hydraulic systems. And if you don't have some of these parts, then you can maybe use some wood to glue together a part, to design a part, and use it that way. But they've got lots of different options here. They've got this option where they're using 2 dowels. They've got this part here. I think I might have given you each 1 or 2 of those parts. You might even have the syringe clips. I can't remember how many of those I had to get out, but they have lots of different options for doing hydraulics. One of the most important things is to fill your hydraulic system correctly. You don't want to have any air in your hydraulic system. And so they talk about how you do that here. And they always show these hydraulic systems with colored liquids, and it's not a bad idea to maybe put a little food coloring in your liquids, just so that you can tell which control controls which actuator, right? You have these devices that are one end and the other, and tubing in between. It's hard to keep them straight. So you can label them, or you can just put colored fluid in them, and you know which one goes where. Let's see here. Here they do the gear and the belt systems, the pulleys, and so on. They talk about electric motors, which we haven't provided for you. We're not going to be using that. So anyway, that is the engineering guide. Very useful tool that I will send to you, or you can just paste it out of this guide here. They have an engineering ruler, which you don't necessarily need. We haven't learned how to use engineering rulers. And then the Fluid Power Lab, which I've already given to you. That's your worksheet that you've been doing this week. So those are some good tools. Here they show a sample design of how you might make a hydraulic arm, and I want you to read through this and use this as a tool, a guide, to design your own options for the hydraulic arm. And again, I would like you to come up with 3 options or so, and they don't have to be terribly different. You could have 3 options that are pretty much the same, except for 1 or 2 things on it that make it significantly different, so that you think it will perform differently. And I want you to go through the process of choosing the best one, and I want you to enter these things in your logbook, just like we always do. And it seems like a laborious and boring part of the engineering process, but it's extremely important. And the more you do it, the better you will be at it, and the more effective you will be as an engineer. One thing that I would like to point out is that they have this, in their design, they have this hydraulic that controls this little fork at the end of their design, and it opens it and closes it. And I would suggest to you that you wouldn't necessarily need that kind of precision control to pick up a tennis ball. There are other options for picking up a tennis ball, many other options. And I would recommend that you think about that. So the project is, and I'll repeat it once again, to build a hydraulic arm using the parts that I've provided. This worksheet that is going to give you some ideas on how to get started on some designs and some possible design features. And maybe the engineering guide that you could use to learn how to work with the materials you have and to design with the materials you have, to start a logbook for this project, of course, and in the end, to make a hydraulic arm that will lift a tennis ball from the floor. It will just be sitting on the floor, and to lift it up 12 inches. You don't have to move, you don't have to have it rotate or anything else to pick up the tennis ball. We will place the tennis ball right in front of your machine, and it will be your job to just pick it up. In fact, you can even place the tennis ball up against a wall if you'd like, in front of your machine and pick it up. Very simple idea, and we will do this probably until Wednesday, possibly till Friday next week, and then we will talk about the next project after we finish this one. We have any questions about this project? I do have some dowels, and okay, I can send you a couple more each, and let's see, if I send those today, they'll probably arrive, they might get in the mail later today if I send them right now, and so they might get there Monday or Tuesday, so yeah, I can send those today. What size? Okay, I can send you a couple of syringes as well. Anything else? Any questions? All right, well, go ahead and finish up your fluid power lab. Email me with any questions you have. Get started on this, of course, as soon as you can, as soon as you're done with your fluid power lab, and we will be projecting away. Have a good weekend.